Well, hello again, my dear friends. Hello once again. In the first part of our video, we discussed about standard operating procedures. We gave a general overview. Now we will try to elaborate on that by including some examples. So let's start. I decided to start from this example that is very informative. So this is an excerpt from Operations Manual Part B. Of course, I deleted the name of my company because this is not for public use. So what we see here the document and item from the document number 2.5.1, and it says pre-flight procedure first officer. And so we see here clearly what a first officer should do once he is in the cockpit. Before that, so as the number implies, previously there are items numbered 2.1, 2.2, etc., which encompasses the duties that should be done once we arrive in the... Actually, it starts from the briefing room. But concerning this one, what it says, MCP setup and selections belong to the pilot flying. So, flight director, switches, courses. Then it says engine out acceleration altitude will be set as a reference using minimums selector for takeoff. What does it mean? Let's come here for our virtual cockpit. This is an EFIS panel, EFIS control panel, and we see here selectors, radio, called minimums, radio and baro. So we will set this selector to baro and dial altitude, let's say 1500 feet, which will be shown here on the altitude tape as a green reference. And this altitude will be set and will be used in the unlikely event of engine out, when that we will know at which altitude to accelerate to flaps up speed. Then there are directions regarding entering fuel quantity in the EFF weights section. EFF stands for electronic flight folder. It gives a default value to be used as a fuel density in case fueling company doesn't provide that information. Then document says during pre-flight check, check that generator drive disconnect switches and alternate flap master switches, 3 red guard close switches are lock wired with breakaway safety wire. These are these switches, alternate flaps and generator disconnect. So a first officer that does this procedure needs to make sure that breakaway safety wires are in place. That means these toggle switches was not operated during the previous flight. Yeah. What comes next? It's recommended to use wing lights, especially during night operation in icing conditions. And the most important part is here, cockpit preparation sequence. So it says preliminary pre-flight procedure first, then pre-flight procedure, thereafter obtain ATIS, calculate maximum takeoff weight and announce to the captain, set captains standby and first officers altimeter and check RVSM. What does it mean? First officer, after getting ATIS, which also includes QNH information, will set 3 altimeters, and the first officer needs to check that captains and first officers altimeters comply with the required tolerances, which are as follows. If the aerodrome elevation we are taking off from is below 5,000 feet, then our altimeters should agree between each other within 50 feet and with the aerodrome elevation within 75 feet. If our altimeters do not comply with these requirements, we cannot operate into RVSM airspace. If the aerodrome elevation is above 5,000 feet, let's say 6,000 feet, then our altimeters should agree with each other by no more than 60 feet. So discrepancy should not exceed 60 feet in this case. So this is example, just one example of standard operating procedure, and this is a normal procedure. Normal procedure means it is done on a daily basis, and normal procedures are done by reference to memory, by recall. So normal procedures, basically these things should be known by heart. However, there are procedures that are not done on a daily basis, and these are called supplementary procedures. One such supplementary procedures are, for example, we arrive at the aircraft and we start from a cold and dark. So I will try to do it by memory. Actually, I don't have to remember this procedure because it's a supplementary procedure. I can just open the operations manual and read and do it. But as I remember, it is like this. We check that battery switch is on. Actually, we put it on. Then we check that wipers are parked. Thereafter, alternate flaps off. Landing gear is off and 3 greens here. What else? And probably window heats off. So we basically make sure that there are no consumers of electricity that will operate once we put the battery on. Yeah, also we put this standby power on, we ensure that this is guard closed. So this is an example of supplementary procedure. Then what I wanted to show is an example of how actually SOPs help us. Let's look here. This is a checklist for engine fire or engine severe damage or separation. That means this checklist is a reference when one of these occur, engine fire or engine severe damage. All checklists start with condition. Condition says that we should use this checklist if one or more of these occur: engine fire warning, airframe vibrations with abnormal engine indications, and engine separations. And checklist tells us which actions need to be done. It says auto throttle if it's engaged to disengage, thrust lever of the affected engine close after confirmation, engine start lever of affected engine again cut off after confirmation, engine fire switch of the affected engine pull. Then comes item number 5, and memory items are complete. With this, then we can read the checklist. I think you would agree that the action of pilot will actually differ depending on when this emergency arises. Meaning, Probably if it happens just after V1, we will be more concerned with maintaining aircraft direction on the runway and safely completing takeoff. Yeah, we will not straight promptly jump into performing these memory items, even though it may be engine fire. Yeah. So here, when standard operating procedures come into play, and they clearly tell us what to do. So this is again should be known by heart by a pilot. Each pilot should know its role in case this emergency happens, this case of emergency. And it says that if engine fails after V1, first what should be done? Pilot monitoring should call out engine failure or engine fire. No further details are announced, and master caution or fire warning should be cancelled. So if it happens, pilot monitoring just presses this button or this button to cancel the warning so that it doesn't distract us. Then at we rotate, the pilot flying will rotate as if nothing has happened. Again, pilot monitoring will call positive rate, pilot flying will call gear up, pilot monitoring will set landing gear lever to up and also acknowledge by replying, by calling out gear up. Then we climb like this till 400 feet radio altitude. At 400 radio altitude, pilot monitoring will call 400. Then the pilot flying may wish to engage autopilot or continue to fly manually. It depends on his choice. In case he continues to fly manually, what he will do next, he will call heading select bank 15, and what pilot monitoring will do, he will put this selector to bank 15, this line, and press heading select. Then pilot flying may request the desired heading in order to maintain the departure runway track. Let's say we departed from the runway with a heading 343 and wind was, let's say, 030 knots. So from the right 20 knots, in order to maintain that departure track, pilot flying will, for example, say give me heading 350 to maintain the following track. We will follow this on the navigation display on this one. Yeah. Thereafter, we will start to do this checklist. We will call, pilot flying will call engine severe damage memory items or engine separation memory items. How do we identify between what has happened? We will check engine indications. If there is no N1 rotation, at least in a simulator, it's taught like this. If there is no M1 rotation, it's implied that severe damage, engine has sustained severe damage. If there is EGT is high and fire warning, that means fire, and if there are no indications, that means engine has separated. Then call auto throttle disengage and disengage auto throttle. Then again, as you see here in the checklist in the QRH written by Boeing, they do not specify which flight crew member does this action. Yeah, just say close, cut off, pull, but it doesn't say who should do this: pilot flying, pilot monitoring, or should it be done by captain or by a first officer. However, standard operating procedures clearly tell us who does which action. So pilot flying will disengage auto throttle and put his hand on the respective thrust lever then he will say thrust lever number 1, for example, or number 2, confirm close. Pilot monitoring will check visually that the pilot flying put his hand on the correct thrust lever and will say number 1 confirmed. After this, the pilot flying will close the respective thrust lever. What happens thereafter? Thereafter, pilot monitoring takes over and continues memory items by cutting off that engine, again with a confirmation by a pilot flying. Then he will pull the engine fire switch, which is here. Let's say if engine number 1 is on fire, he will pull this, and if after that we see engine 1 overheat here and illuminated, this fire switch illuminated, we will rotate to 1 stop. We will make sure that right bottle discharged illuminates in case we rotate it to the right, and we will start timing 30 seconds. We will start timing 30 seconds, and we will see what happens next. If fire continues, we will rotate to the other stop, hold again for 1 second, and wait for bottle to be discharged. So as you see, there are cases when Boeing in its QRH doesn't specify which flight crew member does which action, and standard operating procedures take care of that. What I wanted to tell you next is limitations that may differ between aircraft manufacturer and company. For example, Boeing says that normal flap positions for takeoff, meaning a pilot may take off with the following flap settings: 1, 5, 10, 15, and 25. However, company says that flaps 1 takeoff is not allowed. So we take one further step towards safety, and we say, okay, that's good that Boeing lets us to do, but we will not take off with flaps 1. Next example that I wanted to show is, for example, one more limitation that Boeing says that 737 NG aircraft is able to take off with 15 knots of tailwind or land. However, company says that's okay, we will accept this limitation, but in case the runway is not dry, or takeoff run available is less than 2,500 meters, our limit in this case is 10 knots. Even though the takeoff performance allows you, or landing performance allows you, this is company limitation. This is just one more step towards safety, to promote safety. Okay, basically this is all I wanted to show here. What I want to show next is the difference between OMA and OMB. So let's take a look at this list of requirements that a candidate should satisfy in order to be eligible for a captain upgrade. Yeah. Obviously, this has nothing to do with aircraft operation, but still, this is company policy. So everything that affects the company policy in general, but doesn't affect aircraft operation in particular, is written in OMA. So, for example, here we see that to be eligible for a captain upgrade, you need to have at least 3,000 flight hours, out of them 1,500 on the aircraft with 27 tons or higher maximum takeoff weight, etc., etc. This has nothing to do with operation of aircraft. So imagine if your company operates a mixed fleet. Let's say you operate 777s, also Embraers, Airbus A320s, etc. The policies that are applicable to all aircraft type will be outlined in OMA. One example taken from OMA, the requirement for rate of climb and rate of descent. It says that within 2,000 feet before reaching the assigned level or altitude, rate of climb or rate of descent should not exceed 1,500 feet per minute, and within 1,000 feet of reaching the assigned level, again, rate of climb and descent should not exceed 1,000 feet per minute. Again, this is regardless of aircraft type. This holds true whether you fly Boeing 777s or you fly CRJ 200s. You should, as a pilot, you should observe this rule, and this will be written in OMA since this is common for all the fleet. One more example, commencement and continuation of approach, again taken from OMA. Yeah, it says the commander or the pilot to whom the conduct of the flight has been delegated can commence the approach till 1,000 feet above aerodrome elevation, regardless of reported RVR and visibility. Again, since this is a common procedure for all aircraft type, this is written in in OMA, not in OMB. So OMA is a document containing standard operating procedures and policies that are applicable to all the company, and OMB is a document that describes only type-specific things. Or another example, flight time limitations. Yeah, so let's say if your flight duty period begins between 7 in the morning, 7 a.m. and 1:30 in the noon, and you are flying one or two sectors, you can fly. Your duty may be 14 hours. Yeah, if you fly five sectors, your duty time is limited with 12.5 hours. Again, this is written in OMA since it applies to all the company. So that is pretty much it that I wanted to share with you. I hope now you have understanding what is standard operating procedures, what is OMA, OMB, what's normal procedures, what's abnormal procedures, emergency and supplementary procedures. So I wish you healthy days and goodbye. See you. Bye bye.